Okay, so now let's go ahead and take a look at how this happens for double bonds. These ones are called sp2 hybrid orbitals, and we're going to do this with C2H4. So the difference is now I have two C's that I have to work with, but I still have these four H's. So let's go ahead and create our electron dot structures, our electron configuration drawings for a carbon. Like last time, they have 6 electrons, so I have an up, a down, an up, a down, and then 2 up electrons right here. So 1 and 2. And just as a reminder, I have this same exact thing happening over here on the other side. So I have 1 up, 1 down, 1 up, 1 down, and that means I need 2 more electrons, and since they are in the p orbitals, I'm going to make this an up and an up. Oops, sorry, wrong one. Let me leave that one there. Here's my next up. So as you can see, I have 4 hydrogens. So this time I'm going to draw the 4 hydrogens up here. 1, 2, 3, and 4. And let's see what happens when we try to bond these electrons. So there's 1 electron up here, 1 electron up here, 1 electron up here, and 1 electron up here. So as you can see, it's always good to have symmetry. So what a lot of you will do is try to create a bond over here, a bond over here, a bond over here, and a bond over here, which could work out perfectly. But the one issue is you've bonded 2 electrons to one carbon, 2 electrons to another carbon, but there's no way to link this carbon to this carbon. So take some time and think about what we can do to solve this. And remember, we want to create hybrids. So take a look at what we did in the past and see how we can do that same problem for here. So as I undo this, what we're going to want to do is make sure we can create a hybrid for this section. So like last time, we noticed that this orbital is empty, but we would like to have an opportunity to bond there. So in order to do that, I need to move up this s orbital. So I'm going to move this s orbital up here, and what's going to happen is this electron is going to be willing to share into this p orbital, right? And let's make sure it has a parallel spin, so I'm going to move it up here. And on the other note, this orbital would also like to bond, so why not create an sp hybrid, have this s orbital mix with these p orbitals, and at the same time move this electron over, and let me change it for its parallel spin. And now let's see what the possibilities are. So like last time, I could move this into here, and this electron can share with this electron. And just for symmetry's sake, let's say I move this electron in here, which will then allow these two to share. Once again, I can create this electron bond right here so that these 2 electrons can share orbitals. And again, for symmetry, these electrons right here can share. So now let's take a look. Are my H's bonded to my carbons? Yes. Well, now I need to have this C and H molecule combine with this C and H molecule. So let's take a look if we have any electrons that are allowed to share. If you notice, this electron can easily share with this electron here, and sometimes it can go back and forth between here and here. At the same time, I can also have this electron right here jump in with this electron right here. So what kind of bond did I just create between these 2 carbons? Good, so I'm hoping you said I created a double bond. Our first bond is right here, and our second bond is right here. While I have 4 single bonds that connect each of the hydrogens on here. So let's do a structural formula on the next page just to see what that looks like. here it is. Alright, so to draw my structural formula, I had a C over here and a C over here. And just like our picture, we linked them twice. And each carbon had its own H's. So here is our structural formula for C2H4. So now we have to figure out, well, what kind of shape is this? So just like our previous drawing, we are going to need to draw our orbitals. So I'm going to have my C orbital right here. This is where I said we're going to have to be very creative with what we decide to do is. I have the C orbital here, the C atom right here, and I have another C atom right here. And if you'd like to see a better picture, go ahead and turn to chapter 8.3, and their 3D pictures are a little better than mine. So what we see is we are going to have our orbitals that are slightly hybrids, right? Have these orbitals here that are also hybrids. And we're going to have that extra p orbital in that infinity shape. Okay? So I'm going to group these. I'm going to group these so that it's easy to kind of see what happens when I move them around. So I group that. Oops, I want to group this whole thing. Oh. Okay, so unfortunately that's not going to work. But what we're going to see is we are going to create these bonds. So the first thing we'll see is we have two H's on each side. So here's an H right here, as well as an H over here, an H over here, and an H over here. And just to label these are H's. And if we were to try and show our bonding, let's take a look at the axes that they bond on. And so if I take a look at the axes, this bonds in the same axes, this bonds in the same axes, this bonds in the same axes, and this bonds in the same axes. And they're all single bonds. So these ones are our, let me pick a color I haven't used yet, are our sigma bonds, right? So here's a sigma. So right now I have 4 sigma bonds. Then we said we have 2 connections right here in the middle between the C's. So what we notice is this orbital right here is going to somehow get closer, and this orbital right here is going to get closer, and this creates that first bond. And this, you notice this bond is also on the same axes, which means that it's our 5th sigma bond. Right? And so these electrons can now move back and forth between here. Now that last pair we notice is in this py orbital, and we have to figure out how can I create a bond, because sometimes it's up here, sometimes it's down here. Just like we did last time, if these bonds get closer and closer together, what we notice is, and let's use this color. Let's use this color right here. What we notice is the top part's going to break and create a sausage-like orbital up here, as well as the bottom. And what we'll see is that a bond will occur, but since only 2 electrons can be in this orbital, sometimes that bond will be down here, sometimes that bond will be up here, sometimes it's down here, sometimes it's up here. But I've created this double bond between these carbons. The first bond is here, the second bond is here. Now the problem is this bond is no longer on its axes, unlike these ones. These ones just merged together and created one big bond. Whereas this pink orbital is split into 2. And anytime that happens, we get our pi orbitals. So we're going to call this, we're going to call this purple section, or I'm sorry, light pink fuchsia section are pi bond. So our double bonds are an sp2, and what we see is we have sigma bonds, but we also have one pi bond right here. Perfect. So go ahead and take a look at that. Try and see if you can do this for a triple bond. You'll see this in the next video. But as long as you can get this idea of the hybrids right here, create this picture right here, then we should be okay. And we'll do a lot of practice with this. So good luck with that. And I will have the SP or the triple bond video up in a minute.